All right, so today we're going to start geometric transformations, and we're going to be focusing primarily on translations today. Our lesson objective. In this lesson, students will learn about the concept of transformations and isometry. Students will understand translation and will be able to describe translations in the coordinate plane. So our bigger topic that we're starting now are called transformations. And what those are is we're taking shapes on the coordinate plane and we're moving them around somehow. And there's different rules for the different types of transformations. Isometry, well, we'll get into isometry in a little bit. We're going to start with the transformation called translation. And we're going to explore that today. So let's review. What does it mean for two geometric figures to be congruent? We haven't actually talked directly too much about congruency, but congruency is basically that all corresponding parts, sides, and angles of the figure are congruent. Another way to view this is that one figure could be moved in such a way that it would perfectly overlap the other. Okay, those are great, but it still doesn't get to the heart of the matter. Congruent really is another fancy word for equal. So we've talked with line segments that these two segments are the same length, so they're congruent. It deals more with measurements than it does with just straight up numbers. So you're going to see the word congruent a lot in geometry throughout the year. Congruent really just means equal. That things are equal to each other, they're the same. All right, so can you describe a way that rectangle ABCD could be moved to overlap EFGH? So basically you're taking that figure and you're going to do something to make this be right on top of this. And how would you describe how you could do that? All right, so this is a great answer that I just shared with you guys by moving ABCD 7 square units to the right. That's cool. Yep, you could absolutely slide it over 7 units. I love how specific that is. Because A is going to line up with E, and that's cool. Flip it across to the right. You're completely correct. With this particular setup, this shape could flip over because it has what we call symmetry. We're not talking about symmetry today. If you move the coordinates to the right, so yeah, you're going right. Flipping it, yep, you sure could. Moving it to the left, I think you moved this shape, the EFGH shape over here. You're supposed to move A, B, C, D, but that's okay. At least you kind of knew, like, it needs to go 7 units to overlap. Like, that's still pretty good. So nice work on that, guys. All right, transformations. A transformation is the term used to describe a change in position, shape, or size of a given figure. We refer to the original figure as the pre-image and the result of the transformation as the image. This always confuses students because they hear image and they think that that's the original. So think of pre-image as being like a prequel. Like, I'm sure you've watched a movie and then some prequel comes out where it was like the movie before. I know the X-Men have done this. But there's all kinds of movies. I know horror movies, there's some of those. They have some, I'm not super familiar with horror movies, but they have prequels where they go back and tell the backstory on stuff. So pre-image is the thing that came before. It's the original. And image is the thing you get after you're done doing whatever it is you need to do. Transformations. If the pre-image and the image are congruent. Now remember, I talked about congruency. Congruent means equal, so they're the same. Then the transformation is an isometry. So in this case, you can see this triangle, it's shifted down to here, but it's the same basic triangle. I could pick up the image and put it on top of the pre-image and they would line up exactly. That's isometry. Does the transformation shown appear to be an isometry? So when you look at these two triangles, are they what we call an isometry? I'm going to give you a minute to think about it. Okay, so the people who answered said yes, so that's great. When we look at this, an isometry is the two shapes would be the same, where if I pick this up, I could plop it on top of this, and they would line up exactly. And they absolutely do. So you guys are correct. Those of you who answered, yep, absolutely an isometry. Good job. All right, we're going to watch a brief video. And whoop, there it goes. So you have your pre-image, that's your original, and it slides down to the image. And you can see the translation moves all the points from the pre-image by a given distance in a single direction. So a translation is a transformation that slides all points of a figure by fixed distance in the same direction. The pre-image slides over to image. A translation is an isometry. In fact, that's a really good way to check yourself when you're doing translations. If it seems like the two shapes don't quite look the same, you may have, slid something about that shape into the wrong position. Your shapes should look identical. They're just in different locations. Which of these is not a translation? Give you guys a minute to think about it. All right, so if we look at these four diagrams here, these four things, the answer is A. The reason A is not a translation is because the only way to get this L-type shape to face this way is by turning it or flipping it. But with a translation, we literally keeping the shape on the table. Normally, I give you guys some pieces. I have all kinds of like little geometric blocks that slide around really well on some grids that I have. And you just slide. You physically slide it around. If you have to do anything but something you could do by sliding it, like it's like playing Tetris, I guess, where hopefully some of you play Tetris. Just realized how old I am. But if you're playing Tetris, right, if you just move the piece back and forth and then hit the down button and make it slide, those are all translations. You're good. But the minute you have to press one of the buttons to turn it or whatever, then it's no longer a translation. That's actually rotation, which we'll talk about on another day. So half of you got it right. And that's a good start. Right, because the figure is flipped over. Translation in the coordinate plane, horizontal translation. The figure below is translated right by 7 units. So if we took A, and we said we're going to move to the right by 7, it adds 7 to the x coordinates from the original figure. So we have A, our x coordinate is -5. So we could take -5 and add it to 7, we would get 2, which this x coordinate is 2. Another way that a lot of students prefer is, okay, we have to go right by 7. Then they'll say, okay, here we go. 1, 2, 3, 4, 5, 6, 7. I don't think you can see that, but and you move to the right 7. And then B, you'd move to the right 7, and D and C. You'd move every single point, you'd count over 7. And that's how you'd get to the new location. And as you can see, this is also an isometry. These two shapes are identical. I could pick this up and stack it right on top of that without changing anything, and they match up perfectly. Vertical translations are going to deal with your y coordinates. So if you're moving down 5, you would have your A point, and it would go down by 5. 1, 2, 3, 4, 5. I could also take our y coordinate, which is 6, because this would be at -2, 6. And I could subtract 5 from the 6, because the 6 is the y, and y deals with vertical. It deals with your up and down when you're graphing points. So if we subtracted 5, because we're going down, we subtract, we get down to 1. So, and you can see that that's true for that point. There's a formula that looks like that for translations. All right, so translation in the coordinate plane, horizontal and vertical translation. The figure below is translated right by 7 and then down by 4 units. So it looks like this in the formula, where you have x plus 5. You're going to the right. That shouldn't be x plus 5. That should be x plus 7. And then down by 4, the y minus 4 is correct. This should have been a 7. So yeah, you go right 7 and then down 4. So you can still do the counting. You can just 1, 2, 3, 4, 5, 6, 7 across. And then you can go down 1, 2, 3, 4. And you can still wind up in the right places. But now you got to move in both directions. But once you have a more complicated translation like that, which you're going to have a lot of them, be very mindful about which one goes with which. The x is horizontal and y is vertical. All right, which of the following describes the translation shown? Give you guys a couple of minutes to think about this. All right, let's take a look. So this translation, we're going over to the right. 1, 2, 3, 4, 5, 6. We're going down 2. So right 6, but we're missing the y part for A. For B, you have them backwards. Anybody who picked B? All of you guys got it right, actually, but yep, and C is the correct answer. You add 6, and then you go down 2. So you're putting 6 with the x, and a -2 with the y to indicate you're going down. And the last one is just a -1. It should be positive. All right, lesson summary. A transformation is a change in position, shape, or size of a given figure. The original is called the pre-image, and the result is called the image. If the pre-image and image are congruent, then the transformation is an isometry. Translation is a transformation that slides the figure of a fixed distance in a given direction. Translation is an isometry. We can describe translations in the coordinate plane by looking at the change in x and or the change in y. So it can be one or the other. It's usually going to be both. All right. So go ahead and give this a whirl. There's 4 questions. I'll give you guys a chance to work on those. And then we will wrap up.